You will be introduced to the skeletal system in this screencast. The information shared in the screencast may be found in Chapter 6 of your textbook. This screencast was designed to help you achieve the following objectives: describe the functions of the skeletal system, describe the two types of bone tissue, and describe and identify the four types of bone, the organ. There's an old saying that in order to understand where you are and where you're going, you really need to know from whence you have come. We started the semester after briefly introducing you to the human body. We started discussing the basic unit of matter, which were atoms. We talked about how atoms interact to form molecules, how molecules interact to form organelles and cells, the basic unit of life. Then we discussed how cells, similar in structure and function, work collectively to form tissues. Now, finally, through our discussion of bones and joints, we arrive at the organ and organ system level of organization as we discuss bones and joints, which are the essential components of the skeletal system. So we're now going to talk about our first organ system, the skeletal system. Skeleton comes from Greek, and it means dried up body. And if you look at a bone, it looks like a little dried up, unremarkable object. But if you really think about the skeletal system, it is quite a remarkable system. Here you have an organ system that is responsible for protecting essential organs of the body: your brain, your spinal cord, your heart, your lungs. And therefore, it has to be very hard and rigid. At the same time, it has to be flexible, and simultaneously, it also has to allow for locomotion. So even though the skeletal system must protect the body, it also allows for incredible freedom of movement. I mean, think about all the different dance moves and acrobatics and gymnastic moves that the body is capable of performing. So to me, the skeletal system is a remarkable organ system. One of the functions of the skeletal system is to provide support for the body. Many organs are anchored to the bones and cartilages of the skeletal system. The bones of the leg act as pillars supporting the upper body, the body trunk, as well as the head when we stand and when we hold our head erect. The rib cage supports the thoracic wall, to which many organs of the thoracic cavity are either directly or indirectly attached. Can you imagine life without a skeletal system? What would life be like? Probably something like this. Another function of the skeletal system is protection of soft organs. The skull completely surrounds the brain and protects it from damage. The spinal cord is surrounded by vertebrae. The vertebrae collectively form the vertebral column, protecting the spinal cord from damage. And the organs of the thoracic cavity, or thorax, are protected by the rib cage. The skeletal system allows for movement due to the attachment of skeletal muscles. Skeletal muscles are attached to bones via tendons, As the skeletal muscles shorten or contract, they pull on the bones and use the bones like levers, causing them to move at joints. Another very important function of the skeletal system is storage of nutrients. Fat, for example, is stored in the medullary cavities of bones. These are internal cavities found in bone, which you will learn about shortly. Minerals are also stored in bones, principally calcium and phosphorus, although there are others. 99% of the calcium in your body and a good percentage of the phosphorus is found in your bones. Calcium and phosphorus levels in the blood are very important, calcium especially. So there is this constant cycling of calcium and phosphorus between the bone and the blood. If calcium levels in the blood fall too low, calcium will be pulled from the bone and deposited or enter the blood to raise the calcium levels back to the normal range. Likewise, if calcium levels in the blood get too high, calcium will be deposited on or in bone, removing it from the blood and reducing the calcium levels back to the normal range. This cycling of calcium and phosphorus between the bone and the blood is under hormonal control or under the control of the endocrine system. The fifth and last function of the skeletal system is the production of blood cells, or hematopoiesis. Both red and white blood cells are formed in the red bone marrow. In infants, red bone marrow is pretty much found in every bone of the body. As we age, more and more red bone marrow is replaced by yellow bone marrow, such that as an adult, hematopoiesis only occurs in the flat bones and also in the proximal epiphyses of the humerus of the arm and the femur of the lower appendages. There are 206 bones in an adult skeleton. All 206 bones are composed of two types of tissue. And I'm going to illustrate those two tissue types by using this figure here. This is a cross-section of the proximal end of the humerus. That is the bone located in the brachial region of the arm. Compact bone represents about 80% of the bone tissue of the body. It is homogeneous. It has no spaces. When you think of a bone and when you have observed a bone, you were pretty much looking at compact bone tissue. Spongy bone, which represents about 20% of bone tissue, has lots of little open spaces. That's where it gets its name, spongy bone. And it's composed of little needle-like pieces of bone all pulled together. Spongy bone is much more flexible and allows for compression. You will tend to find spongy bone in areas of the body where there is movement, like around joints, and also comprising a large percentage of bones which are designed for protection. And I'll explain why shortly. Now that we have discussed bone, the tissue, let's talk about how we classify bone, the organ. Bone, the organ, is classified by shape. We have long bones, short bones, flat bones, and irregular bones. First, long bones. Long bones are typically longer than they are wide. They have a shaft with heads at each end. They are composed mainly of compact bone. All of the bones of the appendages are long bones. The exceptions are the carpal bones of the wrist and the tarsals of the ankles. Short bones are cube-shaped. They're composed mainly of spongy bone surrounded by a thin layer of compact bone. These bones do not bear any weight. They are the bones of the wrist or carpals and the bones of the ankles or tarsal bones. These bones slide past one another with ease and allow for the complex movement that occurs at the ankles and at the wrists. Flat bones are thin and flattened. They are usually curved. They consist of a middle layer of spongy bone sandwiched between two outer thin layers of compact bone. And this arrangement is designed for protection. We find flat bones making up the skull surrounding the brain, as well as comprising the ribs and the sternum, which protect the organs of the thoracic cavity. The inner layer of spongy bone acts as a shock absorber, helping to protect the organs from mechanical energy and trauma. The last type of bone, the organ, are the irregular bones. Irregular bones are irregular in terms of their shape, therefore they don't really fit into any of the other categories. In terms of the distribution of spongy and compact bone, however, they are most similar to the flat bones. They consist of an inner layer of spongy bone sandwiched between two thinner outer layers of compact bone tissue. Examples of irregular bone include the mandible of the jaw, as well as the vertebrae and several bones of the pelvis. So to review the objectives of this screencast, describe the functions of the skeletal system, describe the two types of bone tissue, describe and identify the four types of bone, the organ. The next screencast discusses the anatomy of long bone and the microscopic anatomy of compact bone.